All right, let's take a look at today's lesson. This is on oblique triangles. We've done a lot of work with right triangles. The SOHCAHTOA thing, the ratios for sine and cosine and tangent and so forth. We've done a lot of work with that. We did some work with this last year with oblique triangles, the law of sines, law of cosines, etc. We're basically just a review. If you were in that class last year, this is a review. If you weren't, that's okay. We're going to spend a day on each of these lessons anyway. So let's remind ourselves or learn for new. So what is an oblique triangle? It's one that we don't, that's not necessarily a right triangle. So the three angles are something different. So this is the kind of the guidelines or the characteristics that we look for when we decide which one of these formulas we're going to use. In general, when we have side, angle, side, or side, 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 if that's what we're given, we would use law of cosines. That's what we do in general, okay? Because law of cosines works well with sides. If, on the other hand, we have angle, side, angle, or angle, angle, side, we would use law of sines. Now, I don't know if you remember or not how those are worked from like back in geometry, back in the day, so side, angle, side, like that would be where you had perhaps, I don't know, you knew this was like 3 and that was like, I don't know, 75 degrees and that was like a 5. So this means side, angle, side. Remember, they're in sequence right next to each other. Does that ring a bell? How to read side, angle, side? Then side, side, side is just, you have the measurements of all the sides. Then if we're talking about, angle, side, angle, so maybe and that's a terrible triangle. It's okay. Let's pretend that is a good looking triangle. Okay, we're going to pretend that's a horrible looking triangle, but it's okay. I'll try not to focus on that. So let's say this is like a 60 degrees, and that's like a 4, and that's like, I don't know, 25 degrees. This would be angle, side, angle. So I've got an angle, and then a side, and then an angle. So, and they're all in sequence right next to each other. And then angle, angle, side would be the scenario where, we had, let's say we had this angle was, I don't know, 26 degrees, and maybe we knew this angle was 55 degrees. So angle, angle, and maybe we knew this was a 5. So angle, angle, side, again, right in an order, this one, angle, angle, and then side. So just a reminder of how you would read those off of a triangle and determine which you could use. Now, if we're just given 3 angle measures of the triangle, we can't solve it. We have to have at least one side measure to be able to solve a triangle. We cannot solve it with just 3 angle measures. That would be impossible. All right, so that's just a recap. So let's look at the formulas themselves. So the formulas, we've got law of cosines. Okay, so this little guy. So law of cosines. The one thing that we want to really, really be sure we remember is that this side measure and this angle measure must be opposite each other. We don't really care about the name of them. They don't have to be named C, but they must be opposite of each other. Opposite of each other. Okay, that's a requirement. I call them like the bookends. They're like the, whatever you want to say, the ends, the book ends. This is the beginning and the end of the formula. Those have to be, that side measure and the angle measure have to be opposite each other, or this will not work. These two side measures, it doesn't matter what order you put them in, it makes no difference whatsoever about those side measures, but the other side measures make a tremendous amount of difference. Then for law of sines, we rarely do 3 in a row like this. This is just demonstrating that all 3 of those, those fractions are equal. Sine A over A is the same thing as sine B over B, which is the same thing as sine C over C. Okay, and one note we want to make here is law of sines can not find an obtuse angle. It is impossible. Law of sines cannot find an obtuse angle. Law of sines can use an obtuse angle in the formula. You can use it, but it can't find it. Okay, so if we suspect that we have an obtuse angle, we need to be sure to be very cautious to work around that. And we'll talk about some ways to work around that. Okay, we okay so far? Okay, so while we're on this topic, let's just go ahead and let's talk about law of sines real quick. All right, so let's say this side measure is, I don't know, 10, and then I have a 5 and maybe a 2. Okay, so let's think back to our work with geometry. According to this scenario, and we'll name this triangle ABC, just, I don't know why, just ABC. In this scenario, which of the angles is definitely going to be the largest one? Angle C. Angle C is definitely going to be the largest one because it's across from the largest side measure. So we would never want to find angle C using law of sines. We would never do that. We could find any of the other, we could find angle A using law of sines or angle B using law of sines. We should never look for the largest angle using law of sines, just to be cautious, because in case it's obtuse, we won't know it. Okay, so I'm hoping that maybe that rings some bells, maybe that helps, or are we okay with that? We understand that is really the only detriment of law of sines, is that we have to work around it to find obtuse angles. Okay, all right, so we have just 3 examples to do, and then we'll have, of course, you know, it's impossible to do one of every single kind. I'm just trying to give you like an overview. We'll have some more, you know, a lot more to work with in our homework, but here I'm just going to give you an overview. So let's go ahead and draw our triangle. Just a random triangle. Let's see, side B is 5, side C is 7. The measure of angle A is 39 degrees. So we've got side, angle, side. And when we have more sides than angles, we would lean towards law of cosines. Okay, so I need to make, let me fix this B, it's down a little bit low. I only know one angle measure, so that's going to have to be what I'm going to use. So my anchor is this straight across from each other. All right, that's my anchor for law of cosines, and this would be like an A. Right, so that's what I'm going to begin and end the formula with, are my A and angle A scenarios. So we've got A squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 39 degrees. Okay, so I just filled out the formula. A squared equals 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 39 degrees. Okay, is everybody okay so far? All right, what I'm going to do now is I'm going to pull up my calculator. I'm going to work alongside with you just to make sure we've got our calculator input down very well. So if I go to my calculator, and you can go to your calculator, we're going to add the calculator portion page. Okay, and so let's see, what was it? It was 7 squared plus 5 squared minus 2. And I don't trust this calculator. I'm going to write 2 times 7 times 5 times cosine. Now make sure you're in degree mode. Right up here in the corner, it should say degree. When we're dealing with triangles, we deal with degrees, not radians. I mean, all the rest of the time we do radians, but with triangles we do degrees. And that was 39 degrees. Okay, so we hit Control Enter because, you know, it does crazy stuff when you just hit Enter. And that's our value. That's what a squared is. So let's go back. It's 19.5997. So let me go back to the document and let's write that in there. So I know that a squared is 19.5997, and I don't, I don't round. I just leave it all in there. So what am I going to have to do to get to a? I'm going to have to square root. We're going to have to square root both sides. So a is going to be, so let's go back to our calculator. So I'm going to do my square root, which is right here above the x squared. So it's Control x squared. Now to pull that value down, I'm going to use my arrows right here. I'm going to arrow up and highlight it. And then I'm going to hit Enter, and that's going to stick it right there. Okay. And then I'm going to hit Control Enter, and that's going to give me my decimal approximation of 4.427. Okay, so A is going to be 4.427. So let's pull that back up. So 4.427. And that's our first example. How are we doing? Okay. Let's take a look at our second example. So let's draw our triangle. X, Y, Z. Let's see, side X is 3, side Y is 7, side Z is 9. They want us to find the measure of angle Z. That's what they want us to find. That's great. We have side, 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 which means law of cosines. Okay. Even if they didn't tell me to find angle Z, I would want to find it first anyway. Why would I want to find that one first with law of cosines? Because it's the biggest one. We can trust law of cosines with the biggest angle. We can trust it. Once we find that, we can use law of sines, anything, you know, as long as we want, but we can't trust the biggest angle with law of sines. So I would do that one anyway. So let's set it up. We have our, if you will, here's our anchor, right, straight across from each other. So we've got 9 squared equals 3 squared plus 7 squared minus 2 times 3 times 7 times cosine of angle Z, which we don't know what that is. Okay, so what I'm going to do is I'm going to take 9 squared, and I'm going to subtract 3 squared and subtract 7 squared from it, and then continue on that way. So let's go to our calculator, and let's do 9 squared minus 3 squared minus 7 squared, and that gives me 23. Okay, so this is good. So I have 23 equals, let's see, 2 times 3 is 6, 6 times 7 is 42, so negative 42 cosine of z. Now, this is what I don't know. I don't know what z is, so I need to solve for the unknown. That's what we do in equations, is we solve for the unknown. So I need to divide both sides by negative 42. And so I have 23 over negative 42 is cosine of z. Okay, so to get to z, what I want to know is z. I arc cosine each side. Do y'all remember that from before? Arc cosining each side. So I'm going to have arc cosine, which is cosine to the negative 1, of negative 23 over 42. And arc cosine of cosine is just z. So now it's just a matter of putting it in my calculator. Okay? So we're going to do inverse cosine of negative 23 over 42. So let's go to our calculator. So I go to trig, I want inverse cosine, which is that cosine negative 1. I want to do a fraction, which is control divide. And let's see, it was negative 23 over 42. Does it matter if I put the negative with the 23 or the 42? Does that really matter? No. No, that doesn't matter. It doesn't matter. I could even stick it out front if I wanted to. Any of those three places is perfectly fine. Now, to get my decimal approximation, I have to hit Control Enter. And I have, oh, this was an obtuse angle. So that's a very good that we used law of cosines with this one. So 123.204 degrees is what we ended up getting. So let's go back over here and put that in. So angle Z, so the measure of angle Z is 123.204 degrees. Okay. Bringing back any memories? I hope, yes, it's not too bad. Okay. Last one. So let's do that triangle. Boy, they sure do love ABCs and XYZs, don't they? You think maybe they could do some other letters? Maybe, I don't know. MNO, something, I don't know. Okay, that's just silly. I just need to keep moving. So A, B, and C. All right, so let's label it. And by the way, we really need to be drawing out these triangles. Please do not try to do one of these problems without drawing the triangle out. I know you won't believe it, but I have seen some students try it, and it usually is a big fail. So please draw the triangle out. Okay, so side A is 8. Measure of angle B is 64 degrees. Measure of angle C is 38 degrees. I have angle, side angle. Angle, side angle, we want to use law of sines. Okay, all right, we can do that. Okay, it's law of sines though. It's law of sines. So we don't know what the third angle is, but, and that's the one we have the 8 with. That's a bit of a problem, isn't it? Don't we need that. Can we find out what angle A is? Can we do that? We can, can't we? What do we know about triangles? What's the sum of their measures, or the angle measures? 180. It's 180, so let's find that angle. So I've got 180 minus 64 minus 38. Of course, I have a calculator, so I used that. And that gave me 78. Okay, so let's just put that in there. So that's 78 degrees. I'm just putting it in a different color to remind myself that I calculated that. That wasn't given to me. I calculated that myself. And as I check my work, that just helps me know, hey, maybe I made a mistake there. Let me double check. All right, so we can set up the first one. So sine of 78 degrees over 8 equals, let's see, they want us to find side C. So then we should use angle C. So sine of 38 degrees over C. Now I'm going to go ahead and cross multiply. I'm going to get this ready to put in my calculator. It's not ready yet. So let's see, 8 times sine of 38 degrees equals C times sine of 78 degrees. Now if I'm solving for C, what should I divide by? What should I divide by? I want to get C by itself, so I'm sine 78. So I need to move sine 78 over. So C is going to equal 8 sine of 38 degrees over sine of 78 degrees. Okay, great. So let's go to our calculator. So we're going to do 8 sine 38 degrees over sine of 78 degrees. Okay, so I'm going to do a fraction. 8 times, because I don't trust the calculator. Sometimes if you don't put the times there, it won't recognize it, and if you do, it does. So I always put it there, just again, because I just don't trust it. So 8 times sine of 38 degrees over sine of 78 degrees. And of course we want to control enter, so it gives us an approximation. So 5.035. Okay, so let's go back. So C is 5.035. Let's see if that makes sense. Let me put that over here. 5.035. Does it make sense that the side opposite angle A would be bigger than the side opposite angle C? Does that make sense? It does, doesn't it? If we got a number bigger than 8, should we be concerned? We sure should. Because if you recall, it's perfect. It's perfectly matched. The biggest angle is across from the biggest side, and the smallest angle is across from the smallest side, and the medium angle is across from the medium side. It's exactly perfectly matched. Okay?